All right, let's continue on with example 2, part C. We want to determine whether or not this graph is representative of a function. And so if we were to use the vertical line test, notice that really the only place that we have probably concern about is right on the y-axis. If I created like the vertical line here, we probably want to ask ourselves, is the vertical line test intersecting our graph here and here? Well, I want you to notice that in this upper point here, it has an open dot, which indicates that our graph is not covered at that point. And because the lower point is right here with a closed dot, that is part of our graph. So the vertical line test tells us that this is in fact a function. Because of the vertical line test. Again, the open dot means that it's not part of our graph, and the closed dot means that it is part of our graph. So now let's talk about the domain and the range. Okay, so remember that the domain is the x values. So notice that like our leftmost point starts right here and our rightmost point starts right there. And notice that when we're drawing it, it's continuous and not stopping. So all of the values between these two x values. So how do we write that in interval notation? Well, this left numeric value right there is -3, and this here is 2. So we want -3, 2, and then the question now is, are we going to use parentheses or brackets? We use brackets when the numbers are included in our graph or our set, which because both of these endpoints have an open dot or open circle, that means they're not included, so we want to use parentheses on both sides. Now let's talk about our range. So remember, range is like the y values or the output values, and notice that the lowest y value is right here, and we're going all the way up to about there, and that y value there is 5, and it's covering all of the values in between there. So our endpoints for our range are going to be 0 and 5. Now, we have to think about this carefully. Are 0 and 5 both included in our set? Well, because we have a closed dot here, that means the 0 is included, and since we have an open dot there, that means the 5 is not included. So these are our final answers for part C. Let's move on to example 3. It says, consider the graph of the function f of x below. Use the graph to answer the following questions. Remember from our video, this is called, the way that we pronounce this is f of -2. So all that means is when we plug in -2 into our function as an input, what is our output? So let's find -2 on the x-axis, which is right here. And when we plug that in, kind of like the code into our vending machine, what snack pops out? So we look at that ordered pair right there, and the thing that's popping out, so that ordered pair is -2, 4. So when we plug in -2 into our function, the thing that is popping out is 4. So f of -2 is equal to 4. Okay. B says evaluate f of +2. So we want to find 2 on our x-axis and see where is it popping out our y value. You might think that it's here at 2, but again, there's an open dot right there. So we want to go up to the closed dot. And so that ordered pair right there is 2, 3. That means that when we plug in 2 into our function, 3 is popping out. So f of 2 is equal to 3. Part C says, for what value or values of x does f of x equal 1? All that basically says is what x values or what input values produce an output value of 1. So let's look at our output value of 1. That's occurring at this point on our graph there, and also on this point on our graph here. And if I wrote the ordered pairs for those, that would be 1, 1, and -1, 1. So if we wanted to write a sentence, we could say, when x equals -1 and when x equals +1, then f of x equals 1. Okay? D asks us on what intervals is f of x increasing. Now, remember, just like in English, when we read from left to right. Similarly, we do the same thing when we are reading a graph in mathematics. And so just like you would imagine, a graph is increasing when it's going upwards, reading from left to right. So I'm going to highlight the portion on the graph when that's happening. So if you notice here, between the x values of 0 and 1, the graph is increasing then. And then also at this portion of the graph as well. And so we want to actually write our answer in interval notation. So, and we also want to write a full sentence. So we can say f of x is increasing on the intervals. Whenever we're talking about increasing or decreasing, we usually use parentheses around the endpoints. That can also vary by textbook and who you talk to, but for the purposes of this class, let's just say we'll always put parentheses when we're talking about intervals of increasing or decreasing. So on the interval 0, 1, and let's go back up. The other one was 2, 4. Okay. Part E asks, on what intervals is f of x decreasing? So let's go back up to our graph, and I'm going to erase the highlighted portion. So now we want to see when is it decreasing. And it looks like, notice that there's an arrow here, so the graph goes on forever in the left direction, and it's decreasing, coming down all the way to 0. But again, we have to keep in mind that it goes on forever in the left direction. So the answer for this one is going to be f of x is decreasing on the interval -infinity to 0. Okay? Find the minimum and maximum values of f of x. So let's go back to our graph. I'm going to erase the highlighted portion. Now, the minimum is the lowest point on the graph, and I'm going to highlight that. So that's occurring right here at the origin. But notice that there actually is no maximum, or the highest point does not exist, because this arrow here indicates that it's going to go on forever in that direction. So let's think about how we're going to write our answer for that one. So the minimum value of f of x is 0 when x equals 0. There is no maximum value. Okay, part G. For what values of x is f of x positive? and for what values of x is f of x negative. So f of x is negative when it falls below the x-axis, and there are no values when the graph is below the x-axis or negative. So we're only really asking ourselves, when is f of x positive? So it almost seems like f of x is positive everywhere, but we have to be a little bit careful because remember that 0 is actually neither positive nor negative, so our graph is actually not positive at the origin. So we want to be a little bit thoughtful about how we answer that. So it's positive everywhere up to 0 and then everywhere after 0. We just have to think about how not to include 0, and I'll show you how to write that in interval notation. So let's answer the second part first. For what values of x is f of x negative? F of x is never negative. And then we could say f of x is positive on the interval. So the left-hand side of the graph, we could say negative infinity to 0. And I'm going to put a parenthesis since we're not including 0. And then it kind of looks like a capital U. This is called the union symbol. And just like a union in, like when you think of marriage, a union is a symbol that combines two intervals. And then I'm going to put parentheses 0, comma, infinity. So this interval, the way that we've written it, basically says like we're looking at all of the numbers except 0. All right, see you in the next video.